What I mean by that is there's a procedure in place to do this problem, and I've given you the procedure. You might have to do some thinking on the procedure, but are you applying a standard set of procedures to this problem in order to for an answer, or are you just trying to wildly guess at what you think you should do? I mean that some of you can wrap your mind around this problem, but I'm listening to the way you're trying to explain it to people. And all I gotta do is tweak this a little bit, and your method suddenly has issues. But there's a procedure here. Did you apply a procedure? For example, did you decide on a coordinate system that you would use to analyze this problem? I'd encourage you to do so. Did you take all of your vectors and change them from polar notation to rectangular notation? Did you add together like vectors? And did you then convert those vectors back into polar at the end? That was a set of steps I gave. And are you applying those set of steps in a meaningful way and in a thoughtful way to this problem? Some of you are very smart and that served you for a while. But I'd encourage you to come at these problems with a bit of procedure. And let me just be clear. I know where this unit goes after this. I'm encouraging you, when you have a structure, to start the problem with a bit of structure. Okay? I'm going to establish a coordinate system that I think works for this problem. I'm going to call this the positive x direction and this the positive y direction. Everybody see that as a structure? All right. I have two vectors that I'm adding together. There's going to be the vector of the water and the vector of the boat. Those are the two vectors I'm adding together. The water will have to be broken up into x and y components, as will the boat. So let's handle the water first. I think it's the easiest to handle because of the direction of the water. The water is traveling only in the positive y direction and has no component in the x direction. All good? All right. The boat. I don't know what direction the boat is traveling, but I think all of you would agree that the boat's going to have to travel in a direction consistent with traveling across the river. I don't think that direction is this way. I think if the boat points this way, it won't travel directly across the river. Few of you don't understand the fact that the boat's going to have to travel this way in order to travel directly across the river. Does everybody understand that? Now, I know some of you are just seeing a triangle here. I'd caution you. I just got to tweak it a little bit for your method not to work. But some of you are just saying, but the river is doing this. There, I'm done. There's my triangle. That's okay. That will serve you for this problem only. What I said to you is, we now have something about the boat. The boat's traveling at an angle theta, an unknown angle, but we know it's traveling at 5 meters per second. I can break the boat's velocity up into its rectangular components oriented with my coordinate system. So I'm going to take the boat and recognize that there's a horizontal component and a vertical component. Agreed? This is the opposite side, and this is the adjacent side. Now I am skipping trig. You guys should become good at trig. If you're not, do the triangle practice. Become good at it. You want this to be transparent. This has got to be 5 cosine theta, and this has got to be 5 sine theta. If you can't make it that effortless, you need more practice. Please do more practice. If you had to do the whole sine theta equals opposite over hypotenuse, that's fine. It's just adding a layer more work. Try and make it as effortless as possible. The opposite side's always going to go with sine, and the adjacent side's always going to go with cosine. Either way, you do your trig, you get those expressions for the adjacent side and the opposite side. And I notice that the adjacent side is in the x direction, and the opposite side is in the negative y direction. I'm going to go back to my problem here. The boat in the x direction is 5 cosine my unknown angle. And in the y direction, -5 sine my unknown angle. Any questions about this? Methodical, procedural. I need the resulting velocity to have no component in the y direction. Right? That has to be true. For the boat to go directly across the river, I need the y components of the velocities to cancel out. That seems like a pathway to find the angle, doesn't it? So I'm going to say 5 sine theta equals 3. Add them together, set them equal to 0. Move the 1 over. So sine theta is 3/5, so theta is like 37 degrees. But I also know that this is a 3, 4, 5 triangle now that I know that, right? If you didn't know what the 3, 4, 5 triangle is, well, learn. 3 squared plus 4 squared equals 25. Square root of which is 5. So that's going to make this 4 meters per second. That'll be 5 cosine 37 degrees. Well, the boat's traveling at 4 meters per second. 50 meters at 4 meters per second times t will tell me how long it takes the boat to make it across, which has got to be, what's that? Yeah, 12 and a half, yeah. So, there we go. 37 degrees, 12 and a half seconds. So, this problem was an introduction to what I want you to be able to do. This is not the level I want you to be able to work at. It's just an introduction to the level. Because some of you see a shortcut in here and might have done the shortcut. Yeah, there is a shortcut. So let's get rid of your shortcut, shall we? For those of you who use the shortcut, good on you. I have a runway. Okay. My plane has to travel with an airspeed of 120 meters per second to land. If it goes any faster, it doesn't fall out of the sky. Goes any slower, falls out of the sky too quickly. So the plane has to maintain an airspeed of 120 meters per second. The wind is 30 meters per second, 30 degrees west of north. What direction does the plane have to fly to land traveling to the east on this runway? Okay. Again, the plane has to maintain an airspeed of 120 meters per second. What direction does the plane have to fly in order to land traveling to the east on this runway? This is the exact same problem as the boat problem. Enjoy. What?
I assume the plane is directly to the west of the runway?
I would hope so. It would really be bad for the plane if they routed it wrong. All right, so step 1, apply a coordinate system to your problem. I see your hand. I think there's already a pretty clear coordinate system. But just to be consistent, I'm gonna apply a coordinate system to my problem. I'm lining it up with the runway. Step 2, convert my vectors. Oh, I have one that's clear. So the wind, something like that, 30 degrees west of north. I looked at several papers. I did not see this. I saw various incantations of this. Have your angles correct, please. Just looking at the wind by itself, knowing that this is 30 degrees. Not 30 degrees, I'm sorry, 30 meters per second. I think I have to deal with just this vector first. So, components for this vector include a vertical component and a horizontal component. Seems to me this is the opposite and this is the adjacent. So look, folks, coming around and seeing you stalled bugs me. There's not anything different here. Convert the wind into its component directions. You don't need me for this.
It's still 26.
All right. Look, I've got a couple kids who are having some struggles. So hear me for a moment, those of you who are having some struggles. Right now, all I have written here is the wind. Eventually, I'm going to need vectors for the wind in the x and y direction. I'll need the components that make up the wind. And then I'm going to need the components that make up the plane in the x and y direction. And then I will add them together to get the result of the plane. The only thing I know about the result of the plane is that it has to be due east, which means only in the positive x direction. That's what I know about my answer. So I've had 3 kids basically say they have no idea where to start. I've given you a place to start. And that place was put in a coordinate system that represents the coordinates you will use for this problem. Take one of your vectors and draw it in according to your coordinate system. I've done that. I've taken one of my vectors and drawn it in according to my coordinate system. Now I need to break it up into components, right? Because the actual addition of vectors, which we talked about last week, was to convert all vectors into rectangular, add like components, and then convert your answer back to polar. So if those of you have no idea where to start and are still confused, this is me breaking up the wind, into its component vectors. I've drawn it relative to my coordinate system. It looks like it's going to have a negative x component and a positive y component. And because I understand how a 30, 60, 90 triangle works, I can probably tell you that the opposite side is going to be 15 meters per second, and the adjacent side is going to be 26 meters per second. Now look at me, all of you who said, I don't know where to begin. Any question about where I got any of those numbers from or what I'm doing here? So I'm thinking opposite goes with the sine, right? And adjacent goes with the cosine. So opposite is going to be 30 sine 30 degrees. And adjacent is going to be 30 cosine 30 degrees. Cosine 30 is 0.866, right? What's 30 times 0.866? $26, right? We okay? I would keep decimals if I were you, but I'm not going to write all that down. So we okay with that? We're not done yet. Over here in my little chart, I'm going to put stuff down for the wind. The wind has an x coordinate of negative 15 meters per second and a y coordinate of positive 26 meters per second. Any question at all where those came from? All right, got to deal with the plane now. The plane has to have a velocity that will allow it to land traveling exclusively in the east direction, but it has to fight the wind. So I kind of expect that the plane's going to have a velocity that way. Does that make reasonable sense? Right, I have to counter the wind. I know that the plane can travel at 120 meters per second. That's the airspeed of the plane. It's not how fast it's going to be going along the ground, but it's the airspeed of the plane. I defined airspeed last week. I'm okay to use it this week. I don't know this angle, but I'm going to continue by doing my procedure, which is to take this vector and break it up to its components, which means drawing in a triangle to represent the components for this vector. Using my trig and recognizing that the opposite side is going to be 120 sine my unknown angle, and the adjacent side is going to be 120 cosine my unknown angle. Any questions about where I got those values from? Are we good to move on? It seems to me, looking at that picture, that the x component will be 120 cosine 30 degree, unknown angle. And the y component will be minus 120 sine my unknown angle. Are we good so far? Are we good so far? Well, the only way the plane can travel due east is if I choose an angle that will eliminate any y direction in my resultant. So those two have to sum to be equal to 0. That means 120 minus 120 sine theta plus 26 has to equal 0. So sine theta has to equal 26 divided by 120. What angle corresponds to that? What's that? 12.5 degrees. Specifically, 12.5 degrees south of east. Right? Face towards the east, turns towards the south, 12.5 degrees. You could also write this as, 77.5 degrees? But then you better say east of south. Right? We all good? All right. That's the direction you have to face. There's more, right? How fast is the plane going along the ground? You could figure that out too, couldn't you? That would just mean taking this 12 degrees, putting it here, and doing 120 cosine 12.5 degrees minus 15. This has to be the ground speed of the plane as it lands, which is clearly going to be slower. Now, if you've ever landed on an airport when there's cross breeze, the plane has to hit the ground lined up with the air first. And then once the back tires hit the ground, move the nose, point it down the runway, and put the nose on the ground. Can't do that till the tire's touching the ground first. So if you've ever had a rough landing, that's probably why. Again, this is exactly the same as the boat problem, isn't it? The only real difference in this problem is that the wind was in not a convenient direction, so you couldn't just set up your triangle directly from the vectors given. You had to break your vectors up into components first. Now, smarties, that's not the level you should be working at. The level I would like you to work at is this one. Runways are never perfectly north-south or east-west. Runways generally are angled based on where they fit geographically correct. So what if, just humor me for a moment. Actually, no, you're gonna have to be able to do this. What if I have a runway that is angled 20 degrees away from the east, but I have the same wind a wind blowing 30 degrees relative to north, meaning the wind is still this way. 30 degrees, relative to the north towards the west, 30 meters per second. What angle would my plane have to fly now in order to land directly along this runway? This is the top level, right, for adding vectors? No, there's other stuff that's hard. This is medium level. It's harder, though. Wouldn't you agree? The biggest problem with this problem, more than anything else, is that you guys tend to ignore the first thing I tell you in anything that we do. That's the biggest problem. Because this problem actually can be done very much like we just did the last problem. Now, I'm not going to hold you, but I want you to think about something. Remember when I said you get to choose your coordinate system? In a problem like this, just choose the coordinate system to be lined up the way you want it to be. That's all you have to do, is you change the coordinate system. You'll have to change the angle you use here to line up with your new coordinate system. I finished most of this problem in 3rd and 6th period, but not here. But I would consider looking at this before tomorrow.